Today we're going to be setting up this Proxmox server. But do you know what's even better than a Proxmox server? A Proxmox cluster. Let's go! Hello friends, Mircea here. In this video we're going to be setting up the Proxmox cluster that I will be using in my next few home lab projects. We're going to check out the hardware that ended up going into these servers, talk a bit about the decisions that went into picking specific components. Finally, we're gonna get Proxmox installed and then get some basic config going to have a cluster up and running. We've got quite a bit to cover in this one, so let's not waste any more time and get right into it. Before we start building, let me show you what we're working with. Starting with the heart of each node, or maybe the brain rather, wouldn't the heart be the power supply technically? Anyway, starting off with the brain of each node, we have the Ryzen 7 5700G. It's an 8-core and 16-thread CPU with a base clock of 3.8 and a boost clock of 4.6 GHz. I picked this chip specifically because it was the highest core count CPU on the AM4 platform, which still has an integrated GPU that I could find. In my home labbing experience thus far, having this integrated graphics is really handy, especially when, because we all know it's not a matter of if but when, things do go south and you have to troubleshoot the system. The board that houses this chip is the Gigabyte B550M Aorus Elite. It's a micro ATX board that, on the first glance, might look pretty basic. And that's because it is. But I think that, especially for the price, it has some hidden gems. First off, it's the storage support on this board that I quite liked. It has dual NVMe slots, with the main one supporting the longer 110mm form factor, which is perfect for enterprise NVMEs. The secondary slot takes a bit of a hit, sadly, as it's only PCIe by 2, but at least it's still PCIe 3.0. This gives me a theoretical 2 GB per second of bandwidth, which is still more than enough to saturate a 10 gigabit network, for example, so I'm not really gonna complain. On top of the two NVMe slots, the board also has 4 SATA 3 ports, which are going to come in handy for extra storage like SATA SSDs, for example. Secondly, I think that the PCIe slot layout in this board is quite smart. It has two full-size PCIe slots, at least physically, one of them being by 16 electrical and the other being by 4. What I like about this layout in particular is the spacing. I've seen a lot of boards that put the two full slots right next to each other, limiting the potential expandability. Having them spaced out like this means that I can put a dual slot card in the top slot without blocking the second one. This allows me to put stuff like a dual slot GPU, for example, in the top slot, and then a high-speed network card in the second one. Sure, in this particular case I will lose access to that middle by 1 slot, but that's a sacrifice I am willing to make. The last thing that really sold this board to me is, weirdly enough, the rear I/O. If we take a look there, we can see that it has both an HDMI as well as a DVI video output. Most boards I see nowadays have HDMI and DisplayPort, which, understandably so, but I like DVI as a connector because it has those screws to lock it in place, so I don't accidentally yank the cable out when I slide the server on the rails. This board also has support for 4 memory sticks, so dual channel with 2 DIMMs per channel. Not that this is particularly impressive, especially for a micro ATX board, but I needed to transition somehow into talking about the RAM, so here we are. Speaking of memory, I've got 4 random 16GB Micron sticks that run at 2066 MHz. I got these from a local refurb store for a really good price, and even though I know that AMD chips love faster memory for the Infinity Fabric and whatnot, realistically this will do just fine, and for the price that I paid, I really can't complain. I've got 64 gigs to work with. Storage is where things get a little bit more interesting. Each node gets a dedicated boot disk. I have one 240GB Crucial SSD for one of them and two 120GB Samsung SSDs for the other two. These will be used only as the boot device for Proxmox. Other than that, there's a 500GB drive for local VM storage, Samsung 860 EVO in one of the nodes and Crucial MX500 in the other two. These are intended for local VMs which I don't want or need to be highly available, but only bound to certain nodes. The existence of non-highly available VMs kind of implies the existence of highly available ones too, right? Well, that is why I bought these Micron 2300 enterprise SSDs. Each node gets a couple of these 1TB drives to fill up both of the NVMe slots and eventually, hopefully, set up a Ceph cluster. The important part here is that these bad boys have something that's called PLP, or power loss protection. You see, this is crucial for Ceph because what happens, at least as far as I understand it, is that when it comes to sync writes, a drive with no PLP will write the data to the cache and then wait for the cache to flash to the actual NAND in order to be able to confidently report back to the OS that the write actually happened. On the flip side, a drive that has power loss protection can lie and say that the data made it to flash even though it was only written to the cache, since there is no risk of data loss. The PLP is there to ensure that any data in flight, or in other words, any data currently in the cache, can get flashed to disk even if the power goes out. This is particularly important for Ceph because it does a lot of these sync writes to ensure that no data is lost and to maintain data integrity. But as it generally is the case in life, with great power comes great heat output. As great as these PLP drives may be, they still have some problems sadly. They tend to get quite toasty, so I had to grab some random heatsinks of AliExpress to hopefully keep them cool. I haven't tested this extensively yet, or at all if I'm being honest, but hopefully it's going to be good enough. I guess we'll see that in the next video when we actually set up Ceph. To match these fast NVMe drives, I also wanted some fast networking. Luckily, I came across some guy on OLX, which is like the local equivalent of eBay, and I guess he was either doing a good deed or he had no idea what he was selling. I'm not sure honestly. I got a bunch of Mellanox ConnectX 3 and Kelsio T4 dual port 10 gigabit network cards for super cheap. So naturally, I upgraded my entire server rack to 10 gig. The plan here is to aggregate the two 10 gigabit ports to get a 20 gigabit pipe between all of the nodes for the cluster traffic. This leaves the onboard NIC, the 1 gigabit one, to handle all of the management traffic. So things like the Proxmox web UI and maybe SSH, things like that. The rack mount cases I picked for these are all Intertech. The 2U1s are the 20255s and the 3U1 is a 30255. They're nothing spectacular, if I'm being honest. Intertech cases are fairly cheap and they surely feel cheap too. I don't think I managed to build in one of them without drawing a blood sacrifice yet, and I've had many of the rails fail on me. But back then, when I bought them, I liked these in particular because they are long enough to fit a bank of fans in the middle to keep cool all the components, while still being short enough as to not have to extend my StarTech rack to its maximum depth. Speaking of fans, the 2U cases have a bank of 4 80mm fans in the middle, while the 3U case has 3 120mm ones. Since this rack is in my office, I swapped all of the fans for Noctua ones to keep things quiet. The power supply in the 3U case is a basic Be Quiet 450W SFX PSU, while the power supplies in the 2U cases are the Silverstone TX500, and I landed on the TFX form factor instead of ATX or SFX because it was the only standard form factor that I can fit in a 2U case that has any chance of not being obnoxiously loud. In both cases, pun intended, I had a friend 3D print some mounting adapters to be able to mount the power supplies properly, and honestly, they've been working flawlessly. Alright then, enough talking about parts. Let's get Proxmox installed. Normally, this would be the part where I walk you through the Proxmox installation, but I believe that's pretty straightforward. So instead, we're going to do a speedrun. You just grab the ISO from the official website, flash it on a thumb drive with something like Balena Etcher, plug the thumb drive into your server, boot your server, enter the BIOS and select your USB device to boot from it, and then start the Proxmox installer. Accept the end-user license agreement, select your destination disk to install Proxmox 2, and pick a file system. I'm gonna go with ZFS RAID 0. Select your country, your time zone, your keyboard layout, and then set up your local root account. Set a password and then put in your email, preferably one that can actually receive emails. Pick a network interface for management access, set a host name, an IP address, a DNS server, and a gateway. And finally, confirm all of your choices. Alright, at this point, you should have Proxmox installed in your system. First thing I always do on a fresh Proxmox installation is to fix the package repositories. By default, Proxmox uses the enterprise repositories, which require a subscription. In an enterprise environment, that's fair enough. but this is a home lab, so I'll just switch over to the no subscription repositories. If you access the IP address you configured during the installation at port 8006 in a browser, you should see the Proxmox web UI. So let's go ahead and get this all configured. I'll head over into the node settings, over to updates, and then to repositories. Here I need to disable the Proxmox enterprise repositories as well as the Ceph repositories. Then I will add the no subscription one. Now that I've got the repositories sorted, I'm going to go ahead and update the system. To do that, I'll go into updates and then click on refresh. This will do a sudo apt update for me. Then, when that's done, I'll click on upgrade to do a dist upgrade. While that's updating, because it's probably going to take a while, I'll move over to setting up my networking. To do that, I'll head over to system and then network. You can see here that I have multiple network interfaces. There's ENP5S0, which is my onboard 1 gigabit NIC, and then there's ENP3S0 and ENP3S0D1. These are the two 10 gigabit ports on my Mellanox card. I am going to set up LACP on them to get the 20 gigabit pipe between my nodes. To do that, I need to create a new bond interface. I'm going to give it a name. The default bond 0 is fine. I will select my two devices, so ENP3S0 and ENP3S0D1. I will set the mode to LACP, and finally I will set the hash policy. I'm going to use layer 2+3. One thing to note here, since this is a 10 gigabit device, you might want to also set a higher MTU. To do that, you need to click on the advanced button here. For now, I will leave mine as is, since my network is not yet configured for Jumbo frames. If I click on create right now, my LACP should be done, and assuming the switch is also properly configured, everything should be working. My switches, my MikroTik switches, are all configured using Terraform, as we've covered in my previous video. So this is all set up for me already. If you're following along, make sure to pause the video right now and set up your switches to have LACP and VLAN tagging configured for the ports. Speaking of VLAN, let's set those up next. I have multiple VLANs in my network, and we've covered all of that in the previous video, so go ahead and check that out if you want more details. For now, I only want to connect to one of them. I want to connect to my services VLAN. Before we go ahead, I want to address something here. There are typically two ways to set up your networking in this case. You can either have one VLAN-aware bridge, which all of your virtual machines connect to, and then you set your VLAN tags per VM, or you can create one VLAN interface for each VLAN and then bind a bridge interface to that and have dedicated bridges for each of your VLANs. Both are valid approaches, but I typically prefer the latter. I don't want to have to remember all of my VLAN tags at all times, and I find it much easier to pick from a predefined list of bridge interfaces, which can also have nice comments attached to them to know exactly which interface corresponds to which VLAN. To do that, I will create a new VLAN interface. Here, the name actually matters, since the number of the VLAN interface is also the VLAN tag. You can see here, if I change the name to VLAN 100 for example, the tag automatically gets updated as well. Since my services VLAN has the tag of 1010, I will name my interface VLAN 1010. For the VLAN raw device, I will select the bond that I created earlier, since again I know that my switches are already configured to send tagged traffic down that bond. Lastly, I typically like to add a comment to all of my VLAN interfaces to know what VLAN they are actually bound to, since I'm not necessarily counting on my ability to remember VLAN tags. With the VLAN setup, I can now create a bridge for it as well. I like to name these as the associated VLAN. So for VLAN 1010, I will create VM bridge 1010. If you want your node to have an IP address in that particular VLAN, you can set one here. In my case, I do, so I will configure 10.0.10.21/24. At this point, I can go ahead and click on Apply Configuration. This will persist all of the changes that I made here to disk and then restart the networking service. Be aware that this can potentially break your current network connection, so disconnect you from the web UI. In that case, don't panic if you lose your connection here for a few seconds, but I guess you can go ahead and panic if it never comes back. With that done, let's go ahead and quickly test things out. I will open here my terminal, and using Zellige, a terminal multiplexer, I will open up these 4 terminals. The 2 on the left, you can see, are all SSH'd into my first node, and then the two on the right are each SSH'd into one of the other two nodes. I can now go ahead and start up two hyper servers on node 1 and then connect to them from my other two nodes. You can see here that we are indeed getting 10 gigabits from each of the two servers back to our first one, so we do have a 20 gigabit pipe working. With the network stack configured, let's take a look at local storage next. If I navigate to the Disks tab, you can see here that I have multiple disks available in my system. There's the boot disk which Proxmox is installed to, there's that 500 gigabyte SSD for local VMs that I mentioned earlier, and then there's the two 1 terabyte NVMe drives which we'll use for Ceph in the next video. For now, all I have to do here is to set up my local 500 gigabyte disk with ZFS. To do that, I will navigate to the ZFS tab and then I will create a new pool. I'll call this local SSD, I'll set the mode to single disk, and then I will select my 500 gigabyte disk. Make sure to have this checkbox that says add storage checked to have this new pool automatically configured and mounted in Proxmox as a storage target. At this point, I have what I would consider an absolute bare minimum configuration for a working node. So we can move on to the data center level tasks, right? Well, yes, but actually no. Before we do that, it's a good idea to get the Proxmox cluster going, since the data center level settings apply to the cluster as a whole. To do that, I will use the magic of movie making and have my other two nodes configured identically. With the three nodes all configured, setting up the cluster is fairly straightforward. I'll open up all three of my web UIs and navigate to the data center tab and then to the cluster tab. On my first node, I will create a new cluster and I will call it, I don't know, Proxmox. Then I will select my 20 gigabit network device and I will create the cluster. With the cluster created, I can now copy this join information from my first node and then paste it on my other two nodes. So on the second node, I will go to the data center tab again, then I will go to the cluster and then click on join cluster. I will paste in all of that join information and this will prompt me to put the root password for that first node, and then I will also select my 20 gigabit device here as well. Same thing then on my third node. At this point, all three nodes have joined the cluster and you can see I can manage any one of them from any one of the three web UIs. With that done, I can now go ahead and configure shared network storage for all of my servers. For that, I am connecting via SMB to my TrueNAS box to store ISOs and backups mainly. This gives me centralized storage that all nodes can access. I will navigate to the data center tab and then select storage. Here, I'll add a new SMB share. I'll call this one TrueNAS ISO. I will point it to the DNS name of my TrueNAS box, and then I will give it the username and password I have configured for a service account in my TrueNAS box. If I now click on the shares dropdown, I should be able to see all of the network shares that I have configured in my TrueNAS server. I will select my ISO share and make sure that the content type is set to ISO image as well. Then I'll do the same thing for my backups share. This time I will select Proxmox backups as the share that I want to mount, and I will make sure that the content type is set to VZ-dump backup file. At this point, I should have local fast storage thanks to that local SSD ZFS pool, and then bulk shared storage thanks to my TrueNAS box for ISOs and backups. So there we have it. We finished building and configuring a brand new Proxmox cluster. Not bad for a day's work, if I do say so myself. Right now, this is a very basic setup. So these are three independent machines. Sure, they work well, but they don't work together. In the next video, I'm gonna set up clustered storage via Ceph and then take a look at live VM migration and high availability. This cluster should be able to survive one entire node going down with little to no downtime to the VMs that are actually running within it. Now, I'm curious, are you building your own cluster or are you more of a single server kind of person? And what's your take on doing this all manually versus automation? Normally, I'm against doing ClickOps like this, but I still haven't found a good way to automate all of this yet. maybe an Ansible playbook, though I don't really like Ansible that much nowadays. Drop a comment below and let me know. While you're down there, don't forget to hit the like button if you found this video helpful, subscribe if you haven't done so already, and ring that notification bell so you'll get notified when part 2 drops. Thank you so much for watching, and I'll see you next time.